For today's lecture, you're going to need a periodic table and also a calculator. You will need that for the weekly quiz this week as we move forward for your e-learning day. Formula weights is the topic of discussion that we missed due to the snow. When we're looking at these, you're looking at the formula mass of a unit of a compound, meaning that you're going to take into account all of the atomic masses for that compound or formula unit. We will go over some examples which will probably make more sense, but ultimately you're going to take into account how many of each element are present, and then also the atomic mass of each of those elements, and then add them together as we continue on through. Like I said, probably the easiest thing to do is to do some examples of these. That's where I think sometimes we find out, oh, that's how we do these. When I like to do these, I like to set them up a certain way. That doesn't mean that you have to set them up the same way. It just works for me, and that's why I do it. So when I set mine up, I write out all of the elements that are present as so in the compound that I'm looking at, sodium chloride. I then take into account how many of each do I have? Well, that's where I look at the formula, and I can see that I only have one sodium atom present and one chlorine atom present. Now, I'm going to need to multiply those by the atomic mass that I can find on my periodic table. Now, some of these we're going to round differently than maybe we should, or we're not going to round to whole numbers, and that's mainly because of the homework will be done on Mastering Chemistry, and it rounds things a certain way. So we're going to practice using their rounding so that when we're doing it in practice in the classroom and calculating it, we're in that same zone. So for sodium, you would look on sodium and you just find the molar mass to be 22.99. It would be a lot easier to go in math, would be a lot easier if we just went 23, but Mastering Chemistry does it this way. For chlorine, you're going to need to look it up again and see that it's 35.45. When we see that the math isn't really all that hard, so 1 times 22.99 is 22.99, and then we go with the 1 times 35.45, and we can see that, wow, that was really easy math. The only other thing that we have to do now is add those numbers together, which now we can either add longhand, which I'm going to do for this one since it's easier, or you can use your calculator. Again, some of the other ones that we're going to do, it might be good to have that calculator. So 14, carry the 1, 14 again, carry the 1, and we have 8 point, and then it would be 58.44 as my answer. Now that's not the full thing, because as we learned very early on, a number without a label is just a number. And in chemistry, we need the labels. I talked about this a while ago, and then early on we used AMUs, atomic mass units. Well, we are at the point now, that's not what we're going to do. Instead, what we're going to label it as is the one I prefer, and it's grams per mole. And that's going to help us out, especially moving forward next week, starting on Monday. Let's do another example. This one requires us to actually do the naming part of it. As I said early on, especially in the naming unit, the naming is so important in chemistry. It's how we talk. It's the language that we speak. So we need to put it into the formula. So iron 3 nitrate, the 3 in parentheses, means that it has a positive 3 charge. I need to either A, have my polyatomic ions memorized, or look on my periodic table and see that I have NO3 with a -1 charge. And now I can see that those charges don't match up. I would do the crisscross method because that's the easiest method to find out that my formula for iron 3 nitrate, and I need to put my polyatomic ion in parentheses, is FeNO3 NO3 And so when we see that, this 3 is going to end up being distributed to everything inside that parentheses on the outside. So again, going through my setup, I have my iron, my nitrogen, and my oxygen. I find it easier to even split up polyatomic ions because, again, you're only dealing with a smaller amount. I think at most you'll maybe be able to deal with maybe 5 or 6 elements when you're calculating the atomic mass or the molar mass for these. So here, again, we do our accounting. We see that I have only 1 iron. That's because of here. A very common mistake is for students to actually think you have 3 irons because you have iron 3. But that's not what you look at. You need to look at the formula so that we can see that we only have 1 iron. And when I look at my formula, I can see that I have 3 sodium because that 3 is distributed to the nitrogen, and we will distribute it to the oxygen. But first, we'll see that I have 3 nitrogen. Now, simple math says that 3 times 3 would be 9. So that's where I get my 9 oxygen, because 3 times 3, when I distribute that 3 on the outside of the parentheses, gives me that. Now, I'll find and have to look up on my periodic table the atomic mass of iron, which in this case is going to be 55.85. Now, some of these you're going to actually find yourself memorizing. Don't freak out. It's not a big deal. It's actually quite normal to start memorizing ones that you're going to use a lot. So it's just actually, it's a normal thing. Don't worry. For nitrogen, a lot of times they're just going to use 14, but I know Mastering Chemistry likes to use 14.01. And oxygen, and that's usually the biggest one, is when you look at oxygen, you're going to see that it's actually 15.9994. That would should round out to 16, but for some reason, Mastering Chemistry uses 15.99. So we will use 15.99. It will make your life easier, all right? It has caused stress to many students when you're carrying out these longer calculations if you don't have your calculations done correctly at the beginning. And so now we see 1 times 55.85. Well, that one's easy to do in our head. Oops. There we go. 0.85. Then I can go if you wish, you can go with your calculator and start punching in 3 times 14.01, and you'll get 42.03. And then 9 times 15.99 will give you 143.91. Rounding all these out, I know some people would love to just round them off easily, but it is not suggested as we start doing some of our addition on this. So 5 is 8 is 9, 8 is 7, carry the 1, 5 and 5 is 10, 1, carry the 1, 5 is 10, 1, and we have a molar mass of 241.79 grams per mole. So it's not overly difficult. And some of you will probably just add these in your calculator. That's quite all right. Having calculators that allow you to actually go up back into the calculation area of it will be very beneficial moving forward. I know a lot of your iPads will have it, so you'll be allowed to split screen, but you won't be able to do that on the test. So you will want to make sure that you have an ACT approved calculator handy for class. And the last one has a finding the formula mass or the molar mass of vanadium 5 sulfate. So when we go for that one, let's count up how many of each one we have. And so now I look and I see that I have 2 vanadiums. That 5 on the outside of the parentheses is distributed to everything inside. And I see that my 4 times 5 is 20. Go through. And I actually have to look up the vanadium 5 mass, and I see that it's 50.94. So again, if I don't have them all memorized, neither do you need to have them memorized. And then we can go with sulfur is 32.07, I believe. And then again, oxygen is 15.99. Some of these numbers, again, are going to be a little bit bigger than we normally deal with. So I'm going to punch them into my calculator. So 2 times 50.94 gives me 101.88. And then 5 times 32.07 gives me 160.35, and then 20 times 15.99 will be 319.8. I'm actually going to put this one into my calculator because of all the extra parts that are necessary, and I don't want to make a mistake. So I'm actually going to put the addition in my calculator and find that it's 582.03 grams per mole. That should be all we have for today. This will help you take your weekly quiz because you are going to be asked to calculate this. You're going to be asked to calculate some balancing of chemical reactions as you have your e-learning day.